So, hello everybody, good afternoon, good morning from acontis. Welcome to our first event we do here on LinkedIn. My name is Thomas Waggershauser. I'm Head of Sales and Marketing at acontis. So let me start showing you some details and some ideas what we think will be maybe one step into the future of EtherCAT. And this is why today I will like to share some insights and some ideas on how to operate EtherCAT devices within IT networks. So welcome to this, and let me start to give you some insights here. Just 1 second. So let's maybe, before getting into the tech details or into the real topic about how to operate EtherCAT devices within IT networks, or how possible virtual controllers for EtherCAT can look like, let me give a really short introduction into acontis for those who don't know us. So acontis, we're the experts for EtherCAT software and real-time hypervisors. We are based in Weingarten in the very south of Germany. So you see our nice office building here. And acontis has been founded in 2001 in Weingarten, right where we are still placed. And well, since the foundation, we are focusing on EtherCAT as well as real-time software, especially hypervisors. And 20 years back, we have joined the EtherCAT technology group, and already since 2005, we offer our quite successful EtherCAT main device software, the EC Master. So it's in the field since nearly 20 years, and we're quite proud of that because it's a really one basis for a lot of EtherCAT devices. And of course, we have a broad range of EtherCAT software. So the EtherCAT main device stack is one part, but of course we have a lot of tools to configure, to analyze, but also quite a range of different real-time hypervisors that offer a lot of benefits for use in industrial machinery. And last but not least, so I think we are really EtherCAT experts, because also when we look back into the 20 years of success with the EC Master, we see that more than 1.5 million EtherCAT controllers are powered by acontis software. And this is quite a big number for a small company as acontis. And we want to grow with that. We want to make EtherCAT more successful also in the future. So let's get into EtherCAT. Let's start with something you probably all know. So this is probably how you know that EtherCAT is working. It's the so-called EtherCAT direct mode. And right here with the EtherCAT direct mode, we have basically the main device, the controller, previously called master, which is directly connected to the devices which it's controlling. And these devices are called EtherCAT sub-devices, formerly slaves. And the special thing here is that there's only one device that provides messages to the network, and this is the main device. And so there's one telegram, one message coming from the main device, and then routed through all the EtherCAT slave chips. The interesting thing here is the EtherCAT slave chips use a quite special technology. So the data processing, like taking out the process data to put to the outputs, but also providing the process data from the inputs, is done within the ESCs on the fly. So the cool thing here is really we don't have jitter, we have extremely low latency. So all in over, EtherCAT is really fast. So that's the main thing. It's perfect for motion control, multi-axis motion control, but at the same time, it's quite simple to set up, to configure, to operate. So that's the key why EtherCAT is so successful. Extremely fast, but still simple. But this, of course, comes with some limitations. And here, already in 2004, in the first EtherCAT specification, there was a second operation mode inside the specification. And this is called the EtherCAT Open Mode. But probably no one of you already heard about it. What is the Open Mode? Well, let's have a look. So the EtherCAT Open Mode is using a different principle. If you look to the right, we still have our EtherCAT slave chips that work with the data as you have seen in the direct mode by receiving the message, handling the data on the fly. But the difference is here the first EtherCAT slave device and especially the communication path between this unit and the main device. Because here we do not have a direct connection between the main device and this so-called EOM device. We have a standard IT network with switches, with routers, whatever. Because here we are using standard IT communication methods, using an IP address and so on. So this is really the difference. However, this difference provides a lot of benefits, you will see afterwards, a lot of flexibility, but there's one thing to notice. It's still one message which is sent from the main device and then passed through all the slave devices. But as you see, a switch uses a store and forward mechanism. So it adds quite some jitter and some delay to the whole process level. On the other side, you see within the EtherCAT segment itself, it's still as fast as it is in direct mode. So we add a lot of flexibility. On the other side, there's, let's say, some limitations regarding performance. But let's get into that later on. Let's look at more into the flexibility. Because the flexibility here is really like, if you look into a classic factory, you have the factory building, but we also have the office building. And usually there's some kind of IT network already there. So currently, when you need to put in your controllers to the machines, you need to put them inside the factory, directly at the machine where it's hot, dusty, a lot of vibrations. So the computer or the computing system needs to be quite ruggedized. What we can do with Open Mode is we can split the machine, like this tiny robot on the right side, and the controller. The controller can be placed in a secure environment with, let's say, monitor temperature, no vibration, less dust, like in an IT server room. And it can communicate to the machine using the existing IT network, but still using EtherCAT. So there's no different protocol in between. So this is the flexibility we gain. And of course, we can control multiple machines. We can have a lot of controllers and a lot of machines. So this is what EtherCAT Open Mode offers. How does this look like? So if we have a look at our EC Master, we have the hardware, of course. We need an Ethernet interface for the EtherCAT master side or main device side. Then we have an operating system abstraction so that we can run our EC Master on many different operating systems. And then we have the EC Master Core, so the core functionality, the core software that we provide. And this is basically handling all the EtherCAT data processing, the frame setup, and so on. But it also comes with features to import the configuration so that you can really set up the whole network. On top of this, we have the control application, which is usually done by our customers. It could be a PLC type, can also be some embedded software. So this is the core setup for our EC Master. Then, of course, what we need an Ethernet driver. We have our own Ethernet drivers, which are real-time capable. Because, like I said before, the key for EtherCAT is to have low latency, low jitter. And this can only be achieved by optimized drivers. So therefore, the EC Master includes or comes with perfect fitting Ethernet driver that come with real-time capabilities. So this is our EC Master as it is today. So the cool thing for EtherCAT Open Mode there's only one tiny layer which we add, which is handling the communication types, so UDP and RAW. So because the EtherCAT frame is generated within the core, and here with our layer, we add the additional information which is needed to route this EtherCAT frame through your standard office network, for example. So this is why we already have it in place, and we can use it and we can test it. So, but that's one part. So how does it really look like? So I won't go into much detail, but simply to give you some idea how such an Ethernet frame looks like. So basically, or usually, an EtherCAT device, an EtherCAT slave, does not really care about all those segments within an Ethernet frame. It more or less focuses on two segments. On one part, of course, it checks if the frame is an EtherCAT frame. Therefore, there's a header inside this frame, which simply says this is an EtherCAT message. And then we have the data, the process data inside the datagrams. This is what a standard EtherCAT slave chip sees or works with. But of course, there's way more. And with EtherCAT Open Mode, we are using more of that. For example, if we use EtherCAT Open Mode with UDP, we have a destination and a source address. And if we look into the network using Wireshark, then you will see the source address ending with 150, that's our main device, and the destination address, that's the first slave or the first sub-device with EOM support. And down here within, we see the EtherCAT frame header and the datagrams. On the way back, finally, it's the same. Of course, source and destination are exchanged because the source is now the EOM device and the destination is the master. And you again see the EtherCAT data, including, for example, working counters. So you see this has been really routed through the whole EtherCAT network and then is sent back to the main device. So it's working quite nicely, and it's really still using the same protocol as we are using in EtherCAT direct mode, or you could say EtherCAT as everybody knows. So that's one part. But of course, in a heading, we had a second part. And combining EtherCAT Open Mode with the second part, which is virtual controllers, adds even more flexibility and opens new use cases. But what is a virtual main device? So usually a main device or EtherCAT controller is a physical device. So you have one computing device which is running one piece of software, for example, 1 times the EC master. And then this is able to control one EtherCAT network. A virtual main device looks a bit different. It's still one computing device, one time the hardware, but this hardware is using virtual machines to run multiple copies of the main device. It could be the same setup, or it can be different main devices, of course, depending on the network's controls. So here we have one hardware controlling multiple EtherCAT networks, but in a really flexible way. And how flexible this is, you will see right now. Because there's one way how to use them. You can use a virtual main device with direct mode. This means we need one dedicated Ethernet interface per main device. So the computing unit, or the server as we call it here, needs to have at least 2 Ethernet interfaces. More or less, it would be better to have 3 because the TCP/IP here, you see, is used for configuration, remote management, and so on. But for each EtherCAT network, we need one Ethernet interface. And this, let's say, feels a small step. On the other side, it can be a big step. So if you have networks that need high EtherCAT performance, or if you have a lot of process data to manage, like in measurement applications, then a virtual controller offers the benefit that you can scale the processing power of this main device, depending on the dynamic use case. For example, you have a server with multiple CPUs, of course, and you start with maybe two main devices. Each are quite limited. But then you add more and more measurement devices. And then you see one main device needs more resources in the server. Quite easy if you have a virtual main device, because the virtual machine, you can simply add more memory, more CPU resources without changing the hardware, as long as there's enough hardware available in the server. But this is quite easy. Or you can even move your main device to another computing device. So you gain a lot of flexibility. And on the other side, if you think about this setup, when we have two main devices, they usually need to synchronize or exchange some data, which is often done via TCP or Ethernet automation protocol. But here we can also do this. But in addition, we can use, for example, shared memory, shared files, and so on, which really speed up data exchange between the main devices. And of course, you can run more on the server, like HMI or anything else, using another virtual machine in the server. But now let's combine this with EtherCAT Open Mode. And now this is more like, when I would say, it looks like a tricky picture, but it's due to the flexibility. As you see, we still have our server running the two main devices, but as you see, they share one Ethernet interface. And then the EtherCAT traffic is routed through all the switches, through an IT network, down to the EtherCAT segments, which consists, as seen before, of one EOM device and then standard EtherCAT slave devices or EtherCAT sub devices. And of course, we can have other traffic, surveillance cameras, whatever, anything using TCP or whatever in the same network. This does not disturb. The benefit here is we gain much more flexibility because if we need to add another EtherCAT network, we can simply run another main device in the same server without changing anything, because we don't need an additional Ethernet interface. We can use the existing hardware to the optimum. How this is done maybe can be seen a bit in the software architecture. So if we look into a virtual controller, we have the hardware, we have our hypervisor, and the hypervisor runs virtual machines. In those virtual machines, we can run, for example, an EtherCAT master, and right here you see the virtual controller with direct mode. So this really looks like a standard physical master, maybe running in a Linux environment within the virtual machine. But the key here is, with the direct mode, we can have direct access to the Ethernet interface to have maximum performance, lowest latency. Additional networks can be shared via the hypervisor. So in this case, we have two EtherCAT controllers, but we have the third NIC maybe for use for maintenance, but we can have multiple more virtual machines that run something else like a HMI that is also only connected to this shared interface. When we now switch to EtherCAT Open Mode, there are some changes. As you see, the biggest change here is that we don't have a direct access to the hardware anymore. So we are using the operating system or the hypervisor provided Ethernet interface, which is now a shared Ethernet interface. And we are also using the TCP IP stack within the virtual machines. And we need the EtherCAT Open Mode layer so that the EtherCAT master can provide the EtherCAT frames to the Open Mode layer. And this is then adding the UDP or raw format information, and then the data is routed through all the network layers of the OS of the hypervisor, and then we can share one Ethernet interface for multiple EtherCAT masters. Can be two, can be more, so you're really flexible. You can add, remove, grow, extend the masters depending on your application. So this is really maximum flexibility. So what are the benefits? One, I mentioned already a lot of, it's the flexibility. If you think about virtual controllers in combination with EtherCAT Open Mode, you don't need to have the computing device placed nearby the machine or even within the machine. So you don't need to have this ruggedized computing units that can withstand the temperature, dust, and vibrations. We can extend the distances between the main device and the controlled EtherCAT segments by using available IT switching networks. And we have a slightly increased choice of transport media compared to EtherCAT direct mode. And as I mentioned before, you can of course run multiple EtherCAT networks in the same IT network. We also think this will help, or we are pretty sure this helps to improve the reliability of an EtherCAT network or EtherCAT networks, because the main device can be placed in a secure, protected environment. Secure and protected means, on the one hand, we have a controlled environment, controlled temperature, no vibration, less EMI, no dust, but also protected can mean like access protection. So if you place the main device into the server rack, into your IT cabinet, then usually nobody can access this room without having the correct keys. Think about a typical machine when you place the main device in a machine cabinet where there's no key or a standard key that everybody has. So you can tamper with those main devices much more easier than if they're placed in the IT cabinet. Then having them in the IT cabinet or in the server room also makes it way more easier to have centralized management, especially if they're virtual in running, for example, one server running multiple virtual main devices. Then you can use standard IT mechanisms to update the software, to update the configuration, or to run standard software maintenance. You don't need to have specific applications for each and every type of PLC or so. And a bit different from classic redundant main devices, you can also have secondary kind of cold standby main devices. If one main device, maybe even a virtual one, fails, then you can simply run another machine that is running the same virtual machine connecting to the same network. So you don't need to have any hardware changes, recabling. It's all done in software. It's not that real-time switch over, but it's much more easier because everything is done in software. And then it's of course quite cost effective because you can reuse existing infrastructure. And what we also see is typically if you have controllers placed directly to the machine, they're usually oversized. Either because there's one type of computing device used for all the applications, for all the use case, low end to high end, or because it's simply not known how many performance is needed over time. Here, when we have a virtual controller, we can start small. If we see we need more performance, we simply add more performance, computing performance to this virtual machine. Or if we see that our computing device is overloaded or close to overloaded, then we can move one or two of those virtual controllers to another computing device without having, let's say, any hardware changes, reset up of the whole system. And then, of course, each controller is able to control multiple separated remote EtherCAT segments. So you can really get a high-performance computing device at a low cost in a secure environment and use it to the maximum. On the other hand, EtherCAT Open Mode and virtual controllers have some limitations. Well, we don't want to skip that, so let's have a look in here. Of course, there's something about the configuration. It's a bit more complex. At least you need to add the IP addresses or MAC addresses to enable the EtherCAT Open Mode. Depending on how the IT network looks like, there should be some network optimization, so it can be a bit more complex. Same for the diagnosis. With EtherCAT Direct Mode, the diagnosis is quite simple because it's basically a daisy-chained network, so you easily can identify where something is going wrong. Right now, we add the switched IT network. So we have two networks that work together, and then of course the issues can arise in either part of the network. So it's a bit more complex to run diagnosis. And cybersecurity. EtherCAT direct mode is not using IP addressing. So it's quite cyber secure proven. You cannot directly attack the network, you cannot change the data. So it's really a perfect solution. When we combine the IT and the OT level by using EtherCAT Open Mode, then of course we have also for the EtherCAT messages an element which is the IT level, the IP addressing. So we have simply more attack vectors. On the one hand, we are the IP addressing, but also there are more devices involved because we are using, let's say, transport the messages via switches, via routers. So there's simply more attack vectors which need to be considered. This is why we would recommend to use EtherCAT Open Mode within a protected network. And then the performance can be a bit different because EtherCAT direct mode has really hard real-time capabilities. But when we look at IT networks, they differ a lot. Some networks add large delays, and we also could add unpredictable jitter to our EtherCAT network. So we really wondered about this because EtherCAT is known for being fast. If we are not fast enough, then, well, it won't be a success. But this is why we checked. So we did some performance tests with virtual controllers using EtherCAT Open Mode. Because we really questioned, do we still have this cool, fast, highly powerful EtherCAT sports car? Or do we end up with a kind of Ethernet automation tractor? Well, let's see. Honestly, the good news is we're more on the sports car side still. So how did we do it? We set up a virtual controller for EtherCAT running 2 Linux OSs, which run the EC Master. And these Linux were hosted by a Proxmox hypervisor. So we did not use our real-time hypervisor, but an off-the-shelf known IT hypervisor solution. The Linux as well as Proxmox had the real-time patches enabled and so on to achieve good performance. So basic optimizations have been done. The EtherCAT cycle time was set to 1 millisecond, and we were using raw mode for EtherCAT Open Mode. On the other side, we had 2 EtherCAT networks, both consisting of a backhaul EK1000, which is the EtherCAT Open Mode device, and one additional standard EtherCAT slave chip, in this case, an Infineon XMC. And all was connected through the whole acontis office network. So without any optimizations, and we really tried to place the devices on a test in different network segments. So we have here different network segments for engineering and for office. And so we tried to add as many switches as possible in between. Well, what was the result? So we did several runs, several tests, and just this weekend we did a 93-hour test. It was simply when we start and stop, but it gave us some really interesting information. The key fact is that we have a stable EtherCAT network. I think that's really something extremely important. And what we were really surprised of, the round trip time was significantly better than expected, with an average of 150 microseconds. Round trip time means as soon as the message is sent out from the main device, then it travels through the switched network to the EK1000, then to the other slave chip, and all the way back. So basically the round trip time through the whole network. And also the deviations from the cycle time are quite comparable to standard implementations using direct mode. Of course, we need to say we did not have any backup jobs or something running at the same time. So the network load was medium, but we were really surprised about this extremely good performance, to be honest. But as I mentioned, performance will depend on the local IT network. Therefore, we had think about more performance optimizations because like we used it right now, UDP or RAW, without optimization, we think the data communication will be within a millisecond range or multi-millisecond range, like 10 milliseconds, 5 milliseconds, something. Still good enough for most applications. But we think with standard optimization of the networks using virtual LAN, VLANs, and some other things, we can squeeze it. And maybe in future, TSN or elements from TSN can help to even get into the microsecond range, so hundreds of microseconds range with EtherCAT Open Mode through standard office or IT networks. So depending on the IT network performance, EtherCAT Open Mode can offer good enough performance for many applications, but we simply need to say EtherCAT Direct Mode is still the best choice for demanding applications like multi-axis motions and measurement. But we think we can get really close and at least good enough for many applications where we see that EtherCAT is used in. So, as a conclusion, so we're getting to the end. EtherCAT Open Mode offers way better performance than several other Ethernet control networks, like Modbus TCP or Ethernet IP. Even if we talk about 5 millisecond cycle time, this is, compared to other networks, enormously fast. Of course, we offer much better performance and significantly higher flexibility than classic field buses. So the move from, for example, CAN Open to EtherCAT, there's a second option. It's EtherCAT Open Mode with virtual controllers, offering more flexibility and even more benefits for the future. And you can still choose from an enormously large range of off-the-shelf devices, because within the EtherCAT segment, you can use standard EtherCAT sub-devices. And we still have all the EtherCAT benefits like simple process data handling, easy device installation, and many more. So, in our opinion, EtherCAT Open Mode, especially combined with virtual controllers, simply enhances the flexibility of EtherCAT in many use cases. So we think that there are many more use cases which can be covered. Just some ideas. Maybe in machine automation, what about decentralized workbenches? So you can have one main controller sitting in the office area, and then you have maybe even mobile workbenches, which simply need to be plugged into the existing switched IT network, and then you can control the local workbench via EtherCAT. Or maybe something in process industry, where we have large extensions but low data rates. But here, the large range of EtherCAT slaves can be quite interesting for the applications. Or in building automation, just think about elevators, which commonly use CAN Open, even though CAN Open has quite some limitations regarding cable length and so on. Just imagine if you can use the same process data objects via EtherCAT Open Mode and use the standard existing IT network within the building. Will save a lot of money and will make it probably more reliable. And then, of course, many other applications which need not too high cycle times, but need the flexibility like in maritime ship control and anything else. So we think that EtherCAT Open Mode, after being dormant for 20 years, can be a quite interesting opportunity for many applications. So what do we offer for EtherCAT Open Mode and virtual controllers? One is quite easy. For me at least, we have a feature pack called EtherCAT Open Mode. And with this feature pack, we enable the usage of EtherCAT Open Mode using RAW or UDP within the EasyMaster. So you could even update existing main devices to EtherCAT Open Mode using this feature pack. In addition, we also offer solutions for virtual controllers, which are, and this is based on our knowledge regarding EtherCAT and hypervisor. It includes the feature pack EtherCAT Open Mode, and it includes support for selected hypervisor solutions. And we will offer guidelines and examples how to make best use out of that. So if you want to have more information, I recommend to have a look at our webpage, www.acontis.com. We have a blog which explains EtherCAT Open Mode in detail. And if you go to solutions, we also show some more details on our offer regarding EtherCAT Open Mode as a feature pack, but also virtual controllers. Or what I would really recommend, if you're close by, experience the live demo. Because we took our test setup, put it on a nice rack, and we'll carry it to Nuremberg next week. So you can experience virtual controller, the two virtual controllers I was talking about, controlling two different networks via a switched network at booth 418 in Hall 5 next week at the SPS in Nuremberg. If you cannot join, you can also send us an email to sales@acontis.com, and we can book a one-to-one meeting, or we can send more information, whatever you need. We are happy to help, and I'm glad that I had so many attendees here. And before I close this one here, I would simply have a short look at the chat. And there was one question regarding that the performance, there was only the worst case instance, the frame took only a bit less than 100 microseconds more. And yeah, the question also includes, so we didn't have any dropped frames? Yes, that was the case in this 93-hour test run. Everything was working fine, no cycle time violations. So this is why we were so surprised, and this is why we also spent more time in testing, because it feels too good to believe a bit. But it feels, let's say, we're pretty safe that we can say if you have a multi-millisecond cycle time, EtherCAT Open Mode is a solution you should think of. So that was, I think, one of the relevant questions in the chat. Thanks a lot. I hope you enjoyed this short presentation. And if you have questions, send us an email, visit us at the SPS in Nuremberg, or reach out to our distributors all over the globe, or follow acontis on LinkedIn. Thanks a lot, and bye-bye.